Now we solve that example 3. Okay, we draw our first vector, which is 18 cm. First one, 18 cm. Yeah. Okay, there is our A. 18 cm to your right hand side, and then you need a guideline to measure 45 degree. Okay, 45 degree. So I need this. Okay, so you need a compass to do that. Huh? So this is not very easy to do. Okay, so 45 here. That is a 45 degree, but I need only 15. Okay, so 15 is up to here. So that means this one is 45 degree. So this is my vector B, 15 centimeters. Okay, so my answer will be this one, from the initial point and then the final point. So I measure, I draw this vector first, vector number 3. Okay, that is my vector number 3. So the next thing I need to do is to measure the length. Okay, so the length from here to here is 30.5. Okay, 30.5. So the length is 30.5 centimeter. Okay, now you need to give another information, which is the direction. So our direction, normally we refer to the first vector that you draw. That's the one. So that angle will be here. Okay, so the angle will be here. So this one is what we need to measure. So I call this one alpha. So to measure the angle, you need this again one more time. Okay. Alright. So this angle is roughly 20 degree. Okay. So this one is roughly 20 degree. Right. So that means, how do you write down your answer? Okay, how do you write down your answer in vector? So this is your new vector, right? So you might call this one your C. Okay, vector C. So vector C, which is equal to A plus B, is actually equal to 30.5 centimeter at 20 degree below A. Okay, 20 degree below A. Alright, so that is how we write down answer in vector form. You have two parts. One is the magnitude, another one is the direction. Your direction must refer to something. You cannot simply say at 20 degree. Unless the teacher or the lecturer are nice enough referring to a diagram. Okay, I'll be nice enough. That's why in every of your solution in most physics question, you must have a diagram. Okay, to diagram that was properly labeled and so on, so that we know what you are doing. Sometimes you don't realize the importance of a diagram, because diagram tell thousands, replace 1,000 words just for a simple story. Okay. Okay, another one. Okay, another one. Example number 4. Okay, example 4. Well, you have one vector pointing up, so that length is 20. Okay, 20. So I'll call this vector velocity. Okay, velocity number 1, initial velocity, and then this one is 20 meter per second. Okay, now it's point to the north. Okay, point to the north. Another vector is here. Okay, so this vector has a length of, okay, put it to, let's say 25. Okay, 25. So that one is 25. This one is vector 2, velocity 2, which is 25 meter per second. Okay, 25 meter per second. Sum up these two, minus that two vector. Okay, minus that two vector. So give you some other information. This one is 45 degree. Okay, 45 degree. So that means this one is northeast. Okay, northeast. So to solve this, first we draw vector number 1, because question says number 1 minus number 2. Plus is easy, but minus is slightly different here. Okay, so number 1, you draw first vector. Okay, first vector is pointing upwards. So at 20. Okay, at 20 meter per second. That is your vector number 1. Okay, so I just simply write V1, the value I don't write anymore, and then followed by, you need to have 45 degree reference. Okay, 45 degree reference. So I use protractor again one more time so that I know my direction. There's a problem. Difficult to see. Am I extend that diagram? Okay, so now I have a reference line. Mainly this here. 45 will be somewhere else. Yeah, 45. Okay, so that's my 45 degree. But now my 45 degree is 25. Okay, 25. So that means from here to here. Okay. But see, immediately that's a problem, right? Because if you do like this one is V1 plus V2. But we want minus V2. So what do we do? When you put a minus in front, it actually means this. V1 minus V2 means V1 plus the negative of V2. In vector, when you have a negative sign, it becomes opposite in direction. So that means instead of plus V2, you actually plus the negative of V2. Negative of V2 is the opposite of this one. Opposite of this one, that means it has to go in the opposite direction. So that is how we do it. So the negative direction, I will use green color so that you can see the difference here. So it should be in this direction. Instead of the red one, you're supposed to go to the green one. The direction are the same, direction opposite, but magnitude are the same. Okay, from here to here. So now this green vector is your negative V2. Okay, negative V2. Magnitude the same, but direction is totally opposite. So now, if you go V1, go here, that one is V1 plus V2. But if you go here and down here, that one is V1 plus negative V2, which is V1 minus V2. So that means our answer should be V1 and follow the green one. Okay, so our answer is somewhere here. From here, go to there. So we draw another one, which is much more organized. So we have our first vector. Okay, this is V1, 20. Okay, this is our V1. Now we have 45 degree. So we use this as a guide. Yeah, 45 in this direction, but it is 25 meter per second. Okay, so that one is your negative V2. Okay, so this is your initial point, this is your final point. So we just connect that 2 points together. Now we have this. So now this is your vector. We call it V1 minus V2, which is actually V1 plus negative V2. You can write it that way also. Okay, V1 plus negative V2, so that your answer is V1 minus V2. Okay, so that is how we get the answer. So at the moment we need to do two things. Number one is to measure. Okay, to measure how long is a vector here. So this vector is roughly 18. Okay, it is roughly 18 centimeter. And then another thing is the direction. You want the direction to be measured from here. So we call this one alpha. So our direction from there is, we need to extend that value. So that, okay. So we put it here. Should be something like this, right? This line. Okay, the green one. In your case, if your compass, protractor is transparent, you don't have to do this. Okay. So now this is, I still cannot get a good fix here. Alright, so roughly that is my location. So the angle is from here go to here, so it's roughly 85. Okay, so 85. So the alpha is 85 degrees. Okay, so your answer will written as V1 minus V2 is equal to 18 centimeter at 85 degree from V1. Okay, 85 degree from V1. Right. So that's why I say your angle always refer to the first vector that you draw. First vector from here. This one first vector we draw. First vector from here. Alright. So that's an example for number 4. Alright.